This is a short video on adding and subtracting fractions. The first ones I have here are ones that I would describe as in the easier variety. If I have 1/5 plus 2/5, I end up with 3/5. Notice that the denominator there is still the same. Now, think about this word denominator. You've probably heard it, you've probably been told it. Nom refers to name. That other number we have is the numerator. It's the one that gives it value. So why would we be calling one of them a name and the other one a value? Well, it's giving us a hint. You don't add up names, you add up values. So, when we look at this thing and add it up, what we have is fractions of a whole. If I have fifths, then what I have is 1/5, just like that, just there. And then I have another whole where I am adding in 2/5. The type of thing I am adding together is fifths. That's the name of these things. They are fifths. They will still be fifths when I have finished adding them together. 1/5, 2/5, 3/5. The number at the bottom becomes a name for that type of thing. When you're adding that type of thing together, you've still got the same type of thing. Same happens with 4/7 and 2/7. 4/7 minus 2/7 is equal to 2/7. 4 minus 2 is 2, and we are dealing in sevenths, so it stays sevenths. The same thing happens when the denominators are different, as they are here, but we have a new challenge. And the new challenge is that we have to be able to get them to have the same name before we can add them together. Below a diagram to help understand this. 2/5 plus 1/5. Each of these rectangles represents one whole, and I've got to divide it up to get my fifths. So here is 1, 2, 3, 4, 5, and I'm talking about 1 and 2. There are 2/5. In the other one, I'll have to put a line the other way. This is a half of the whole. So when I add these two together, I can't give them a name that is either fifths or halves because they don't fit in that way together. When I have one whole here, divided up in halves and in fifths, I've got to find another way of dividing up one whole that works for both. And we can see it visually here. If I put a line that way, the same as the fifths, same as the halves, I put a line this way, the same as the fifths, now I can see that I have both of them in tenths. This is 4/10, and this is 5/10. And following our rules from previously, we know that once we have them in tenths, they remain tenths. When we add them together, they don't suddenly become 20ths. Each of these squares is 1/10. When you add them together, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. And that is how we do that question. Now, we don't want to have to draw a picture every time. So what's our method? I need to be able to look at this question and answer what is the lowest common multiple of 5 and 2. And in this case, the lowest common multiple of 5 and 2 is 10. So I need to make both of these things a fraction out of 10 before I can continue. Well, I do that by multiplying the first fraction, top and bottom, by 2, because 2 times 5 is 10. That gets me my 10 on the bottom. And now I have a 4 on the top there. And when I multiply the other one, I'm multiplying by 5. 2 and 5, 1 and 5 is 5, and I can now say 9 out of 10. It is all about identifying the lowest common multiple. You might have noticed in this case that I ended up multiplying by the number at the bottom of the other fraction. It would be a mistake to think that that's always going to be the right way. For instance, if I had a fraction with a 4 at the bottom and a 6 at the bottom, multiplying would give me times by 6 here and times by 4 here, 24. But the lowest common multiple of 4 and 6 is 12. I'll get the smallest numbers possible out of this by multiplying the 6 by 2 and the 4 by 3. I should be looking for the lowest common multiple every time. And that's not always easy, but you need to practice, you need to know your times tables, you need to work for that. Let's look at a subtraction question while we're going. 5 over 6 minus 1 over 5. Well, as it turns out, in this case, I am just multiplying by the number at the bottom of the other fraction. So I end up with 25 over 30 minus 6 over 30 is equal to 19 over 30. Now, a couple of comments here. Yes, in the middle of doing an addition question, we had to do some multiplying. That does not mean that we've suddenly changed what type of question we're doing. Remember the diagram at the bottom. When I drew in the extra line, on one of them, drawing in a line doubled the number of pieces. That's multiplying by 2. In the other one, when I drew in extra lines, I had 5 times as many pieces as before. That's multiplying by 5. If we go back to that question and have a look what I did, I multiplied the half by 5, I multiplied the fifth by 2. I did that because the lowest common multiple of 5 and 2 is 10. That is how this works. Thank you.